Well, hi everybody. It's the most colorful time of the year in Colorado as we get into the month of October. Beautiful fall color, and it looks like it's going to be really good this year thanks to all of that moisture that we had. The aspen trees are very vigorous and in good shape. Barring any major wind and snowstorms, we should be in for some really nice fall color viewing over the next few weeks. So let's talk about October weather. It's an interesting month. Big snows and even some thunderstorms. We can still get thunderstorms on the plains. We've had some hail even in recent years in October, and the first heavy snows of the season typically occur. Now, some of our averages, the warmest October on record was almost 60 degrees for the average temperature in 1950, and back in 1969 it was 38.9, a very cold month of October. The average highs 72 on the first, slipping to 59 by Halloween. 44 is the average low on the first of the month and down to 31 on trick-or-treat time. Our wettest October was back in 1969, also that coldest one. Over 4 inches of precipitation, a mix of rain and snow. Driest, we've had a few, but just a trace of precip back in the Dust Bowl years of 1934. Hottest day, 1892, 90 degrees. That's also occurred more recently on the 1st of October. -2, the coldest temperature back in 1917. And just as recently as 2014, 15, 16, no snow at all in the month of October. But going back to the snowiest, that was October 1969 with 31.2 inches of snow. 1906, 22.7. Boy, I remember this one, the big blizzard of 1997, over 22 inches of snow. 1923, 100 years ago, 17.8. 2009, pretty good snowy, 117.2. Way back in 1897, a little over 16, and in 1929, a little over 16. Our storm threats, we can still get thunderstorms with lightning and heavy rain, but snow begins to become a bigger deal. Hail happens occasionally. We get our first significant cold outbreaks during the month. Right now, our drought conditions continue to get a little bit worse over southwestern Colorado. No drought still Denver and across the northeast. You take this out on a bigger picture, they have a lot of drought across the Midwest all the way down to the Gulf Coast and up in the Pacific Northwest. So we're in a fairly decent spot at the moment. You want to help us measure the storms? CocoRa's, the Community Collaborative Rain, Hail, and Snow Study. You can help measure the storm. We have over 20,000 weather watchers worldwide. Although this program was started by our former state climatologist Nolan Duskin up at Colorado State University back about 25 years ago. You learn how to measure rain, hail, and snow. You get a rain gauge and a hail pad and a snow measuring pad. If you want to become more acquainted with CocoRa's, go to their website, www.cocorahs.org. All right, so what's the outlook? Here's the latest 30-day, and we're sort of in a donut hole, if you will. Warmer to the north, to the south, and to the east. But we are slated to be perhaps slightly wetter here. And notice wetter where we really could use it, where that drought is bad over the southern Great Plains. As we're looking ahead, we do have an El Nino now developing. That's the warmer water in the Pacific, and that is going to determine the jet stream across not only the Pacific, but most of the United States and around the world. And this one could be a really strong El Nino, so it could supercharge some of the global warming that we've seen. And also, with that vast amount of heat going up into the atmosphere, may change around our patterns as we head into the cold season. Right now, the longer range pattern is warmer than average, which doesn't surprise me because the jet stream oftentimes blocks the colder air up into Canada. And wetter than average, the storm track is very often with an El Nino fall into the winter across the southern portions of the United States. Colorado's kind of in between, and we're a long ways from the ocean, so that does have an impact, as El Ninos are not always as deterministic for what our weather is going to be compared to other parts of the country. One thing we are seeing is a trend toward warmer weather with global warming for the fall-winter season, especially in the western United States, and more warm fall days in the Denver area. Since about 1970, the records show about 2 weeks more of warmer days, above normal days, and we're seeing the temperature increase at about 3 degrees in the Denver area, 3 degrees Fahrenheit, and that is, of course, due to climate change. And I talk about this a lot, rapid cyclone development in the tropics, hurricanes, tropical storms, the shrinking of the snow and ice, the record-setting wildfires, the heat waves, and the droughts. That is all connected to what we expect from a warmer world. Interesting, though, there is something that actually brings us some colder weather because of global warming. Locally, regionally colder. It's called Arctic amplification. The warmer temperatures are actually changing the pattern of the jet stream, losing some of that jet stream momentum, and what can happen then is it's more of a meandering, like a slow-moving river rather than a fast mountain stream, and that slower pattern can sometimes mean bulges of cold air. You might remember that big Texas cold wave a couple of winters ago that can drop southward. So it seems counterintuitive that a warmer world could actually produce regional colder weather for a period of time. But so far in this year, most of the world's been very hot. We've been a slightly cooler spring into summer across the West, including Denver, but the world has been hotter. And even though our summer into the early fall has been a little bit cooler, that's not the global trend. The carbon continues to climb. These are the emissions of carbon dioxide in the atmosphere. It dropped a bit during the global financial crisis, and then it also dropped a bit during COVID, but we are seeing now about 38 billion tons a year of carbon going in. That's over 100 million tons every single day from the burning of fossil fuels. People ask me, well, how do you know it's not from something else like volcanoes? And what we can do chemically is measure what's called the isotope of the carbon, and we know that that carbon is actually coming from very old sources. That would be coal, oil, and fossil or natural gas that's been underground for millions of years. And we've seen that rise in temperature about 2 to 2.5 degrees Fahrenheit in the last 140 years. And the increase in that CO2 in the atmosphere traps the infrared energy, the warmth of the Earth, from otherwise going into outer space. It changes the global heat balance, and that carbon dioxide will stay in the atmosphere for centuries. And as I mentioned, it continues to rise every single day. What I'm showing you here, this is the averages of all the different sites. We have Barrow and Mauna Loa, American Samoa, the South Pole. They go up and down seasonally in the northern and southern hemisphere because of respiration from plants, breathing in that carbon dioxide during the growing season. But we measure it, and everyone that I show on my TV Weathercast Daily shows the global average, which is now at about 420 parts per million. When I was born in the 1950s, it was around 300 parts per million, so it's really increased quite a bit. And with that, we see that trapping that heat, warming up. The 10 hottest years globally have all occurred since 2010. And we've seen the changes in the departure from the early industrial era due to that warming caused by the trapping of the heat from the carbon dioxide. And again, that's been about 2 to 2.5 degrees Fahrenheit globally in the last century or so. Now, put this into perspective. The Earth is 4.6 billion years old. Let's scale that down to 46 years, because what we're seeing is how quickly this change is happening. If we scale the Earth down to 46 years, 8 months ago the dinosaurs lived. 4 hours ago human beings first began to exist. 1 minute ago the Industrial Revolution began. And in that 1 minute, we have increased the carbon dioxide in the atmosphere by 1/3, from 280 parts per million to 420 parts per million. Here's how this works. What happens is the CO2 changes the global heat balance, all right? Sunlight warms the planet. That is visible light that we can see. When the surface and the oceans get warm, they radiate back into space infrared. So if you were using nighttime vision goggles, that's what you would see. Increased CO2 traps some of that infrared from going into space, and so the warming since the Industrial Revolution has been about 2 to 2.5 degrees Fahrenheit so far, and it will continue to warm as we continue to add more CO2 into the atmosphere. You may hear about carbon sequestration, putting it back in the ground. Well, let's run some numbers on that. If you put that carbon back into the ground using technology to inject it back into the ground, we add 100 million tons a day. And the price, if we could get it there, it's not yet feasible. The goal is $100 per ton to put it back down in the ground. Run the numbers, that's $10 billion a day just to stay even with what we're putting in every single day, or $3.65 trillion per year. And that wouldn't take out all of that CO2 we put in. It would just keep us even with what we're putting into the atmosphere every single year. It's cheaper to not put it in the first place if we can get there with renewable energy. And it's never too late to stop making something worse. So you can see from the various generations, these stripes, so the warming stripes, the Gen Zs and the Gen Alphas are going to have a much warmer world than a baby boomer like me. I talk about this a lot because I have 3 grandchildren. Many of you, of course, love and adore your children and grandchildren. You want to have the best for them as well. And we can still fix this. If we lower emissions by reducing the amount of carbon that we're putting in the atmosphere from burning fossil fuels, we can have a much better outcome for the future generations. So as I say, it's never too late to stop making things worse, and we're making things better. Most of our emissions are from electricity, industry, transportation in Colorado, but we are, through better technologies now, cutting back on our carbon because of wind energy that is expanding quickly in Colorado and solar energy across much of the South and West. So this is not all doom and gloom. There is some good news out there. We can still fix this. If you'd like to learn more, this is my book. It's the world's littlest book on climate. 10 facts in 10 minutes about CO2. You can use that QR code for a free download. Please download it, share it with your friends. Have a great October. Thanks for listening.